Okay, so we are going to isolate this part right here that has the exponent, the x. So to do that, first thing we're going to do is divide by 5,000. So this gives you 50. And so the next thing is I'm going to multiply by 0.005 both sides. Just put 0.005 here and 0.005 over here. So now I have 1 point, and I'm going to combine these two. 1.005 to the x equals 50 times 0.005 is a quarter, 0.25. And so now I've isolated the base with the exponent, so I'm going to change it to log form. So log base 1.005 of 0.25 equals the exponent x. So x equals log of 0.25 over log of 1.005. So this is approximately negative 277 and 900.951 because we're rounding to 3 decimal places. Okay, so I'm going to change this to e to the x squared minus e to the x minus 6 equals 0. And so I'm going to factor it like a quadratic. So factors of negative 6 that add up to negative 1 are negative 3 and positive 2. Okay, so move over here. So that means that e to the x equals 2 or e to the x equals negative 2. Okay, so this one is going to be natural log of 2 equals x. And this one is actually no solution because this number, you can't have natural log of a negative number. Okay, no matter what I plug in here for x, it's never going to be a negative number. It's always going to be positive. So this part has no solution. So for this one, it's just natural log of 2. So it's going to be 0.693. Okay, since the bases are equal to each other, since it's the same base, it's an equation that has the same base, right, on both sides. So we can get rid of the base and just say x squared minus 3x equals x minus 2 and solve for x that way. So I'm going to move everything to the left. Minus x gives you negative 4x plus 2 equals 0. Now this one does not factor, so we're going to have to use a quadratic formula to solve. Let's see, did I copy it right first of all? Yeah. So we're going to have to use a quadratic formula. So here's the setup, negative b, so it's the opposite of b, so 4 plus or minus the square root of b squared minus 4ac all over 2a. So that gives me 16 minus 8 over 2. 4 plus or minus square root of 8 over 2. And so square root of 8, remember, is 4 times 2, so that 4 comes out as a 2, like that. And I can factor out a 2, and that cancels that. So x is 2 plus or minus square root of 2. Okay, so first thing I'm going to do is get rid of the denominator by multiplying both sides by it. So I'm going to take this here and then multiply it over here on this side and then over here on this side. So then I have 525 equals 275 times 1 plus e to the negative x. Okay, so I multiplied both sides by the denominator. I can divide, well, I guess I can distribute and then divide, or divide and then move the 1 over. I guess I can divide. 275. And so that gives you let me see, just reduce it. So I can reduce it by 25 and I get 21 over 11 equals 1 plus e to the negative x. I'm going to subtract 1. And so that means minus 11 elevenths. So that gives me 10 over 11. Okay. So now I've isolated the base with the exponent, right? So I'm going to change it to log form. So natural log of 10 over 11 equals the exponent. I'm going to divide by negative 1. I'll just put a negative in the front, right? Same thing. Okay, so that cancels that. And so I just take the natural log of 10 elevenths and then take its opposite number. So natural log of 10 elevenths is negative 0.095, but then there's a negative already there, so I'm going to just write it down what the calculator tells me. 0.095 on, so then it's positive. Okay, so 93, change it to exponential, so you get e to the negative 3 equals x, and just punch it in the calculator. So you get 0.04978, so because of that 7, you round it up to 50. So right here. So this one is e to the 1.5 equals 2x. We divide by 2. And then put that into the calculator. So you get x is approximately 2.241. So this one I'm going to add 2 to both sides first, because you want to isolate this part. So I get 2 natural log 3x equals 19. Then I divide by 2. So natural log of 3x equals 19 halves, or you could put 9.5. So this becomes e to the 9.5 equals 3x. So I'm going to divide by 3 and then get a calculator to get the approximate value. So when you plug this into the calculator, you get 4,453 and 0.242. Alright, so for 102 I'm going to divide by 4. And so 11 divided by 4, 2 3/4, so that's going to be log of x minus 6 equals 2.75. And so now I could change it to exponential, so base is 10 to the 2.75, oops, that looks like a 2, 2.75 equals x minus 6, so I have to add 6. So x equals 6 plus 10 to the 2.75. So now you take a calculator to get the approximate value. Okay, and there you have it, 568.341. And that's including the 6. For 105, I have one of two choices. I can just go straight to e to the first equals the square root of x plus 2, and then square both sides to get rid of the radical. So square both sides. So you get e squared equals x plus 2, subtract the 2. And so you would get x equals negative 2 plus e squared. Okay, that's one way. You could also use the properties of logs, where this is to the 1/2. And then, so then this 1/2 goes to the front. So it's 1/2. It seems a little longer though. So I'm going to multiply by 2. And this cancels. Natural log of x plus 2 equals 2. So this is e squared equals x plus 2. Subtract the 2. And so x is the same as that, right? So again, I'm just offering it as an option. Some of you might see it that way easier. So now we take a calculator to get the value. Okay, and after you put in a calculator, you get 5.389. So for 108, I'm going to take this exponent right here and move it to make it the coefficient of the natural log, and then divide by 5. Divide 2 on both sides. So this becomes 2 natural log of x minus 4. Then I divide by 2. So natural log of x minus 4 is 2.5. So this is e to the 2.5 equals x minus 4. So I'm going to add 4 to both sides. So x equals 4 plus e to the 2.5, which is approximately equal to 16.182. Okay, so I'm going to combine these two logs as a single log so that I can drop the logs in the second step. So left side stays the same. On the right, I get the sum of two logs is the log of the product property, like that. So now I can drop the logs, and this becomes x plus 5 equals x squared minus 1, right? When you multiply those two, you get x squared minus 1. So I'm going to move everything to the right. So 0 equals x squared minus x minus 6. So then when you factor that, you get x minus 3. X plus 2 equals 0. So x is 3 or negative 2. And you always go back and check in the original, make sure that the numbers work. So 3 plus 5, that's good. 3 minus 1, that's good. And 3 plus 1, now when I'm checking up here. Okay, so 3 is good. Negative 2, 5 minus 2, that's good. Negative 2 minus 2, that's not good. Okay, so this one doesn't work. Why? Because that negative 2 makes the argument, that's what you call this part right here, the argument makes it negative, and that's not possible. I mean, you can't have a log with the argument being negative. Okay, so I'm going to combine this left side as a single log. So the difference of two logs with the same base is the log of the quotient. So this becomes log base 10. And again, the 10 you can leave or keep. It doesn't really matter. So, and then here I get 12 plus square root of x equals 2. So now I'm going to change it to exponential form. So this is 10 squared equals 4x over 12 plus square root of x. Okay. So we're going to multiply both sides by the denominator to get rid of the denominator. So on the left side we have 100 times 12 plus square root of x. And since we multiplied that on the right side, then on the right side we only have 4x. So distribute the 100. Let's move everything to the right so that 4x is positive. So then I have 4x minus 100 square root of x minus 1200 equals 0. I can reduce everything by 4. So x, 25 square root of x minus 300. So I know it doesn't look like it, but I'm going to treat this like a quadratic. And how can we do that? The x I'm going to change to the square root of x, square root of x squared. And then so here's your 25 square root of x, there's like your x term, and then this is 300. Now this one does not factor, so we have to use a quadratic formula. Okay? So real quick, here you see the work for the quadratic formula, but notice how it says square root of x, not x, because in this quadratic equation, the value that we're looking for is square root of x. Okay? And so here are the steps, just like any regular quadratic formula. So now you plug it into a calculator. So you get square root of x is approximately 3386, so you square both sides to get 1146. The other root